are going to start chapter 7. Lesson 1 is going to deal with fundamental identities. Now, we've already seen all of these identities starting back with chapter 5, but we really didn't do a whole lot with them except for the reciprocal identities. Now we're going to use all of them. We're also going to be reviewing some skills. We're going to be factoring, we're going to be distributing, we're going to be adding fractions, and the fractions are going to have trig functions in the denominator. In lesson 2, we're actually going to prove the identities. What you need to be able to do is to take these fundamental identities, and we're going to use them by substituting in them into different equations or expressions and simplifying them. So a lot of substitution. Now, we've worked with these reciprocal identities here quite often. We've seen that the reciprocal of cotangent is tangent, the reciprocal of secant is cosine, and cosecant is sine. Now, we were shown the quotient identities back in chapter 5, but we never did anything with those. So tangent of theta is sine of theta divided by cosine of theta, and cotangent is going to be, cotangent of theta is cosine theta divided by sine theta. Now, in the problems that we're going to be simplifying today, you're going to be seeing the variable x in place of theta. Just know that x is the angle measure. Theta is just the angle measure. Then the identities, we actually had a problem on our chapter 5 test where they ask you to find the value of one of the trig functions using an identity. And that's going to be the last example that I do, just like we did in chapter 5. Now, as far as these Pythagorean identities go, you should be able to manipulate them and solve for one piece of it. And what I mean by that is, for example, you could take the first one, and let's say instead of memorizing that sine squared theta plus cosine squared theta equals 1, what if you wanted it solved for sine? So what I could do here is subtract cosine squared theta from both sides. And then I can get a different version of this Pythagorean identity because, again, I'm going to be doing a lot of substitution. So, for example, if you had something that asked you to simplify 1 minus cosine squared theta, you could say that in place of it, you could substitute sine squared theta because that's what it equals. So be able to manipulate all 3 of these Pythagorean identities into something that you can use in your problem. Now, everyone, when I teach this, seems to be able to memorize that sine squared theta plus cosine squared theta equals 1. For some reason, that sticks. Everybody seems to get confused with these two. So come up with some method that'll help you remember. Maybe it might help you to think, well, the 2 C words, the cotangent and the cosecant, which are reciprocal ones, they go together, and then the other reciprocal function goes with the tangent. So the 2 C's go together, and then tangent and secant go together. Yes?
It probably doesn't, but is it okay if we were to add cotangent and then 1, or does it have to be 1 and then cotangent?
It doesn't matter the order.
It's probably easier than
Right, because remember, with addition, it's commutative. So you could write it as cotangent squared theta plus 1 equals cosecant. The order of these two does not matter. And they're going to be mixed up in these problems that we're solving. So just be able to recognize it that it is the same thing. So let's go ahead, and today that's all we're going to do is simplify 7 examples. And then I'm also going to do one last example, which was just like on your test where you're finding the value of the trig function. When you do the homework tonight, they're going to ask you to find the value for all 6. And I'm going to explain what that means when I get to number 8. My first example is asking, in all of these examples, 1 through 7, I'm simplifying them. So what I need to do is right now, these 3 trig functions are being multiplied. I am going to replace them with their reciprocals or with something, one of the identities that I know. So I know that the reciprocal of secant is going to be cosine. So I'm going to change secant theta and turn that into 1 over cosine theta. My goal here is to try to get something that's going to cancel. So I could take the cotangent, and I know from my quotient identity that you're going to memorize that it is equivalent to cosine of theta over sine of theta. And then the last one, the sine, I'm not going to change this. I'm going to leave it alone. So sine of theta, and I'm just going to put a 1. Now remember, when you multiply fractions, you can simplify on the diagonals. So what I'm going to do is look for things that are diagonal from each other that I can simplify. So notice cosine of theta, that's in the denominator, and cosine of theta, that's in the numerator. I can simplify those. And I can turn this into 1. They don't necessarily cancel out. It's cosine theta divided by cosine theta, which is 1. I can also do that with the sine. So the sine of theta and the sine of theta, those will also simplify to 1. And now I'm going to multiply what remains. So straight across the top, 1 times 1 times 1 is 1. Straight across the bottom, 1 times 1 times 1. So my final answer here is 1. So this is what we're going to be doing when they ask you to simplify. They're going to ask you to replace and see what you can cancel out or what you can eliminate. We're going to do the next one. Again, I need to replace. This is being multiplied, so I'm going to replace cotangent squared x. Now again, the x and the theta are used interchangeably. The x here is the angle, just like theta is the angle measure. Whenever you're doing these trig functions, you need to have something representing the angle after the word. So then the next thing I also have to figure out is something I can plug in for this. So the first one, I'm going to use my quotient identity, and I know that cotangent is equal to cosine over sine, and it was squared, so I'm just going to replace it with cosine squared x over sine squared x. I also know that there is a Pythagorean identity that states that 1 plus tangent squared x is equal to secant squared x. So what I'm going to do is I'm going to take out the 1 plus, and in its place, I'm putting secant. So I'm going to replace that and put secant squared x. So I could put a 1 there if I need to. I'm now also, because I don't have anything to simplify or cancel, I can now realize that secant is the reciprocal of cosine. So I'm going to replace secant squared x, the red, with 1 over cosine squared x. So I'm going to flip this to its reciprocal, which is cosine. I'm going to rewrite the black side. And this shouldn't have an equal sign in between. Sorry, this should be a multiplication. Let me fix that. I'm multiplying these. So then cosine squared x over sine squared x. The cosines cancel, become 1s. I'm now left with 1 over sine squared x. And again, I'm going to simplify it a little bit more. And I know the reciprocal of sine is cosecant. So I'm going to get this out of the bottom of the fraction. And my final answer here is cosecant squared x. The next one I'm going to FOIL. It's like 2 binomials. Once I FOIL this, yes?
On the test and quiz, would you be allowed to leave it as 1 over sine squared x?
It would expect you to get rid of that fraction if there was a reciprocal identity.
Okay.
Yes, you'd have to simplify it.
Okay.
All right, number 3, we're going to FOIL. So first gives me secant squared x outside gives me plus secant x. Inside gives me negative secant x. And last, when I FOIL, gives me -1. Notice when I go to add my two middle terms, they're going to cancel out. So I'm left with the difference of two squares. So secant squared x -1. There is a Pythagorean identity that I can use for this. The Pythagorean identity is tangent squared x plus 1 equals secant squared x. I'm going to rearrange it so it looks like what I have. So again, be comfortable with manipulating these Pythagorean identities. And this will give you secant squared x -1, which is what I have in my problem here. So in place of secant squared x -1, the final answer is going to be tangent squared x. So be able to rearrange those Pythagorean identities. Everybody good on number 3? Let's try number 4. For number 4, I'm going to pull this apart and break up the fraction and give them each their own sine x as the denominator. So I'm going to write cosine x over sine x, and then I'm going to write sine x over sine x. Now I can use properties that I know and identities that I know. I know that cosine x over sine x, its equivalent identity is cotangent. So I'm going to replace that with cotangent of x. And I know that anytime I divide anything by itself, I get a 1. Now, at first glance, you might think, oh, wait, that's an identity. However, the Pythagorean identities have a square in them. So this would be the final answer here. You would have needed cotangent squared. So there's no square. So this is the final answer. This is not an identity. So there's no square. So this is not an identity. You need the square on the cotangent. So you would leave it like this. For number 5, it's actually an identity, but we need to manipulate them. So for the first one, I'm going to use the Pythagorean identity of sine squared x plus cosine squared x equals 1. I'm going to move the cosine over, or actually move the sine over, and solve for cosine. So you might want to, in addition to memorizing those 3, maybe memorize the manipulated identities, just so you don't have to keep doing this each time. So cosine squared x is equal to 1 minus sine squared x. So that's what I'm going to replace my numerator with. I'm now also going to look for an identity for the denominator, and that one is one that I should know. It's not one that needs to be manipulated. So 1 plus cotangent squared x is equal to cosecant squared x. I didn't need to rearrange this one. So I'm going to replace the denominator with cosecant squared x. All right. I can now realize that I do have a reciprocal in the denominator. So I'm actually going to change the cosecant squared x to its reciprocal identity, which is 1 over sine. So I'm going to leave the top, cosine squared x. I'm going to change the denominator and make this 1 over sine squared x. The black fraction bar means to divide these. So I'm going to do a keep flip change or a state change. So really what I'm doing here is cosine squared x divided by 1 over sine squared x, keep flip change, or keep change flip. So I'm going to keep the cosine the same, flip the sine to its reciprocal because I'm dividing. So sine squared x over 1. So my final answer here is just cosine squared x and sine squared x. If you write it with the sign in the front, you can write it that way either. You don't need a multiplication. You can just write them side by side. That was number 5. 2 more examples of the simplify, and then we'll do a solve. Yes?
Wait, so why isn't the dividing good enough?
Because you don't want to leave it as a fraction.
Okay.
We want to try to simplify it out of a fraction.
Okay.
All right, let's try number 6. Everybody good on 5? Let's try 6. Another FOIL problem. Now this one's going to be a little bit long. So I'm going to show you what we get when we FOIL. However, keep in mind, anytime you multiply a trig function by its reciprocal, you're going to get a 1. But I'm going to go ahead and write it out, put the 2 words next to each other. Then I'm going to change it to reciprocals and show you how I simplify it. But if you can realize when you multiply a trig function by its reciprocal, the answer is 1. So I'm going to do first, and I'm going to get secant x times cosine x. And then I'm going to do outside in blue. And I'm going to get secant, actually it's going to be minus because it's negative times positive. So secant x times sine x. Then inside, positive cosecant x times cosine x. And then finally last, which will be negative cosecant x times sine x. Now I'm going to show how I'm going to get 1s out of some of these. I'm going to change the reciprocals. So I'm going to change secant into 1 over cosine. And I'm still multiplying it by cosine x. So notice here when I multiply this, this is going to become a 1. I'm going to do the blue one. Secant x is 1 over cosine. And then I have the sine x. Nothing cancels here. So let me just go ahead and write it. So sine x over cosine x. The green cosecant is the reciprocal of sine. Going to multiply that. So cosine x over sine x. And then the last one in black, the reciprocal of cosecant. And again, I'm going to change the black. The reciprocal of cosecant is sine. So I'm going to write 1 over sine. And then times sine x. These will simplify. This becomes a minus 1. Good? Because negative times positive is negative. Now, when I go to simplify here, notice the 1s are going to cancel because 1 minus 1 is 0. So now I'm left with negative sine x cosine x plus cosine x over sine x. Now, if you remember from your identities, these are both the tangent and the cotangent. The blue one is the tangent, and the green is the cotangent. I can flip it around and just put like a subtraction sign in between so it's easier to read. You could leave it, but I wouldn't leave a negative out front. So I'd flip it around. One more example. These are actually already Pythagorean identities. So I'm just going to replace and then turn it into its reciprocal. So for number 7, the numerator is one of the identities you should memorize. That 1 plus tangent squared x is equal to secant squared x. And for the denominator, 1 plus cotangent is also an identity that you should memorize, and it's equivalent to cosecant squared x. So let me replace those. So it's now secant squared x over cosecant squared x. I'm now going to replace each of these with their reciprocals. So my numerator is going to become 1 over cosine squared x, and my denominator is 1 over sine squared x. So again, remember, you're going to do like a key flip change. So you'll leave the numerator the same. So you could write that as 1 over cosine squared x. The fraction bar is division, so I flip the denominator to its reciprocal. So this will become sine squared x over 1. I'm now going to multiply these two. So sine squared x over cosine squared x. This is equivalent to tangent. So my final answer here is tangent squared x. Yes?
For the last one, you wouldn't have, put it for the cotangent 1 over tangent because it's subtraction, right? Not multiplication.
On number 7?
6.
Oh, here?
This answer, yeah.
No, I wouldn't.
But if it was multiplying, you would put it 1 over tan and then...
And then simplify, yes. All right, one more example. You actually did one of these on your chapter 5 test. So now we're going to do it again. So again, we could draw a triangle here to solve this, but instead the instructions, just like on your chapter 5's test, said to use an identity. So I'm trying to find secant of x. When you're doing your homework over the weekend, they're going to give you information like this, but instead of just telling you to find 1, they're going to ask you to find the value of all 6. So you're actually going to have to find all 6, sine, cosine, cosecant, secant, tangent, and cotangent using identities. So let's go ahead and do this one. I'm going to be using the Pythagorean identity of sine squared x plus cosine squared x equals 1. Because notice my given information is cosecant. And I know cosecant is the reciprocal of sine. And they're also asking me to find secant, which is the reciprocal of cosine. So if I go ahead and just solve and find cosine here, then I can flip it to its reciprocal. Now, notice they've got a restriction here. They're telling me my answer is lying in quadrant 3. So once I get to the square root part of it, this is going to help me to determine, do I keep the positive or the negative answer? But I'll show you that when we get there. So let's go ahead and I'm going to change cosecant to its reciprocal so I can get the value of sine. So sine is actually going to be negative 2 over 5. Flip it upside down. It's squared. When you did this on the test on the chapter 5, a lot of people forgot to square. So remember, the Pythagorean identity has a square in it. So plus cosine squared x equals 1. I'm going to square the negative 2/5. So this becomes 4 over 25 plus cosine squared x equals 1. I'm going to change the 1 into 25 over 25 because I need to subtract the 4/25. Let me move it over now. So now cosine squared x is equal to 21 over 25. Now, in my problem, they're asking me to find secant of x, not secant squared. So what I'm going to do is I'm going to square root this. So this gives me cosine of x is equal to 21 square root. And I can square root the 25. So it's going to be the square root of 21 over 5. And it's plus minus. However, this is where my given information about quadrant 3 comes in. All students take calculus. They say my answer is supposed to be here. I know the only thing that's positive in quadrant 3 is tangent. So this is why I'm going to get rid of the plus. So my cosine answer here is going to be negative square root 21 over 5. But the problem did not ask for cosine. It asked for secant. And remember, secant is the reciprocal of cosine. So I'm going to flip it upside down. And now I have to rationalize. Multiply the top and the bottom by square root 21. So final answer here is negative 5 square root 21 over 21. Now, in the homework, they're going to say to find all 6. Notice we found cosine and we found secant. So, and then they gave us at the beginning, they gave us cosecant and we flipped that for the sine. So now you just have to find tangent and cotangent if this were a homework problem. And again, plug it into one of the identities. So we did the same thing. We did this in chapter 5. It's coming back. And now we've already seen all of these identities. We really didn't use them. The only ones that we've consistently been using are the reciprocal identities. So your homework over the weekend is going to be 21 through 27 odd and 49 through 61 odd. So find some way to memorize all of the identities on that very first slide, and also the rearranged versions of the Pythagorean identity. Be able to recognize them, so that way when you go to use them, you don't have to sit there and rearrange every time. Okay, so that is 7-1. 7-2, we will be proving things. So again, same thing, we're going to be using the identities and substituting. So that is it for 7-1.